In this presentation, we will introduce Java generics. A generic type is a type that has other types as parameters. It is widely used, for example, in collections, as you have seen in the previous video. For example, we can define a map whose key is a string and whose value is a list of integers. So you see that map is a generic interface that has two parameters, the type of the key and the type of the value. That's very useful because the compiler can type check that your declarations and your method invocations are correct and avoids doing castings. Without generic types, you could define maps, but you would not be able to specify what's the key type and the value type, and therefore this would be much more error prone. How do you declare a generic type? Well, you just declare an interface or a class, and then just after the interface or class name, you put these brackets and declare the parameter types. So you see that a parameter type has just a name, in this case E. By convention, the name is just an upper letter. But you could put here any name that you like. So you see, you don't specify any other information for the moment. We will see that you can, but at the very minimum, you just need to specify the name. And then you can use E as a type. For example, you can use E as a type of a parameter. And of course, you can use E to parameterize other generic types that are inside this declaration. Then, when you are going to declare a variable of type list, you need to specify the concrete type that you are going to use. There is a limitation in Java because you can only use generic types with a reference type. So you cannot, for example, declare a list of int, because int or double are not classes, they are data types, and that's a limitation of Java. The limitation is because of how it is implemented in Java. At execution time, at runtime, all generic type information is lost. In other languages like C++, this limitation does not exist, and you can create generic types that have data types as parameters. Right, this is an example of a generic class whose name is pair. So it is generic because we have declared two generic parameters between these brackets, and by convention these type parameters, the name is in uppercase and normally just one letter. So they can be used as what they are, types. So I can declare here an attribute first of type A, an attribute second of type B. I can use these types in parameters, and remember the class name declares here the type parameters, but I don't need to repeat this declaration of the type parameters in the constructor. So what can I do? I can do things like this. I can create now a pair of string and integers, or a pair of double and a pair of integers and list of strings, and whatever I want to do, right? So I'm just printing the pairs, and by printing I'm invoking toString. Second thing is that you notice that whenever you create a generic type, you can use it in a regular way, what Java calls raw type, because, for example, here I'm in the method equals, I get an object here as parameter, and I need to check whether it is an instance of pair. At runtime, the type parameters are lost, so that the runtime, the virtual machine doesn't remember if this was a pair of integer and strings or whatever, but still the compiler gives me an error because I'm using pair in an incorrect way. So I should be using here pair in a generic way, and because I don't really know what are the types of this, what are the value of these generic types, I can still use the wildcard. This means any type, and in this way I get rid of the warning. Still, the program will not change the behavior and will work as before. Right, let's see now what happens if you need to specify certain requirements for the generic types. As an example, I have created here a class RecComparable that has a generic type A. Then inside this class I'm declaring an attribute elements, which is basically an array list. Then I have here my constructor, which receives a variable number of parameters of type A. I add all these elements to this array, and then I would like to sort. Remember, collection.sort. Sort is a static method that basically sorts this array using natural order. Therefore, I get an error here. Why do I get an error? Well, because sort expects that the collection, that the list is the elements implement comparable, but that's not necessarily true for A. So A may not implement comparable. Therefore, we would need to specify that A is not any type, but it should be a type that implements comparable. How do we do that? Well, in the declaration of the generic type here, I can specify requirements. This is specified with extends in this way. So you see that comparable is an interface, but we are using extends here. Don't get confused. Comparable is still an interface, and when you implement the interface, you put implements. But here, because you are specifying requirements for this type, you always put extends. Right? So now the error is gone and everything works. How do I use this generic type? Well, as with other generic types, when you declare a variable, you need to give here specific types like a string, and then I'm calling here the constructor and passing two strings here. Recall that this is not correct because you are not specifying here that RecComparable is generic, but you need to specify with the brackets. It's not necessary that you put here a string because the compiler can infer what is the generic type here. It's enough to put it here. Recall that generic types can be used in a non-generic way, which is called a row as a row type, but that's not really a good practice, right? You should always use generic types with generic arguments. Okay, so that's how it works, and basically it will print here the list. Nothing very interesting, but I would like to show you that the compiler actually checks that these requirements for types are actually satisfied. So let's say I try to put here a type that does not implement comparable, then the compiler will trigger an error because my class is not a valid substitute for A, because A should implement comparable, right? So that's not required. That does not allow. So what happens now if I need that A satisfies several requirements like being comparable and being serializable, because here I'm going to serialize my objects. That can be specified with this ampersand. To specify, you can always specify more requirements here. For example, something like that. So you put here a number of requirements, and with this symbol here, you specify that this type should satisfy all these parameters. So it should implement comparable, serializable, and clonable, and even you can require that this is also compatible with my class. So you can specify here classes, and you can specify interfaces, but the classes should go first in this list. What happens with inheritance and generic types? Well, you can extend a generic type, and you have two options. In the first option, you declare here a type which is not generic anymore, and you do that by basically extending a generic type but then providing a concrete type for the types of the superclass. So here I'm creating this type here, which is a specific type, a specific subclass of array list of strings. The other possibility is to leave open the parameter types. So I have here again an array list. This time I leave open t, right? And then I declare a type which is also generic. So I have here my list of t. So t is still open, and t should be the same t as this one here. Right, so let's now think about what's the relation between generic types in case that there is an inheritance relation between the parameters. So we have a list of string and a list of object. Recall that strings are a subtype of object. So here I'm creating an array list of strings, and I'm trying to do this assignment. So a string could be assigned to an object, but is it the case that the list of string can be assigned to a list of object like we are trying to do here? Let's think about this. There should be a type error. Well, it is, because even if a string extends object, list of string does not extend list of object. Is not compatible with that. It's not necessarily compatible, right? Because if that would be possible, then I could add a new object to LO. Why? Because it's a list of object. But if that would be the case, I would be able to then get the element and assign it to a string, because ls is a list of strings, right? But that would give me an error because I have placed here an object. Therefore, this relation does not hold. Even if a string extends object, a list of string is not compatible with list of object, and I cannot do this assignment. Let's now think about how to use generic types as parameters. For example, here, imagine you want to create a method print that receives a list and then does something like printing or doing something like that. I want print to be as general as possible so that it accepts any kind of list. So this doesn't really do the job, because here we are expecting a list of object. If I declare a list of a string, I cannot pass it as parameter here, because remember, a list of a string is not compatible with a list of object, and therefore I cannot really do the method invocation. I will get a compile error. So what can you do if I want here to have any type of list of string, list of integer, list of whatever? I need to put, I cannot put object, but I can put what is called a wildcard type, which is the question mark. So list of question mark means list of anything. A declared list of strings, a declared list of integer, a declared list of whatever. Then this question mark will get substituted by this the type that we have at runtime. Okay, so we can declare the parameter as a list of whatever, but then what can you do with these unknown types? Well, every type in Java inherits from object, therefore I can do something like this. I can get the element at position 0, and then I can assign it to an object, because anything that is a reference type can be assigned to an object. This will work. Can we use add to add elements into a list of question mark. No, you cannot. Why is that? Even if I try to add an object, I will not be able to do it because we don't know what's the type of the list. It can be a list of integers, and therefore this would be wrong, right? So to be able to work with wildcard types, what you do is, what Java offers is the possibility to bound these types. You can bound it upwards and downwards. So you have extends, which means I should have here a list of anything that is compatible with vehicle, that is vehicle or any subclass. This is useful because now, for example, assume in this class I have an attribute which is a list of vehicles. Then I can add to this list the list that I have as parameter. That will compile and work because I know that L is going to be compatible with V, because the elements in L are vehicles or any subclass of vehicles, and therefore I can add them all to V. And now I can use this method that follows. So I can declare here a list of car, and car, if car inherits from vehicle, then I could call this method add vehicles with C, because in C I have cars, and car, the declared type, is compatible with this declaration. Basically, is compatible with vehicle because it is a subclass of vehicle. Right, so the other possibility to bound a wildcard type is with super. Super indicates that this type here should be T or any superclass of T. That's useful in certain situations as well. For example, here I would like to receive here a list of what? A list of anything that is number or any superclass of number. And in this way, I know that I can, for example, add this 8 here, because this will be boxed into an integer, and an integer is a number, and therefore an integer can be added to a list of numbers, right? We are safe. And even if the list that I pass here is a list of objects, then I can add a number here. And in addition, I can, for example, add a float, because a float is a number, and adding a float to a list of number or to a list of object is okay. If I use the other bound here by requiring here that my list is number or any subclass of number, then I would not be able to call here add. Why is that? Because maybe my list here is a list of, let's say, instead of floats, is a list of double. Therefore, this would fail because the list that I receive here is a list of double, but I'm trying to add here a float. Therefore, if you want to invoke methods that receive these generic types, you need to use the super wildcard bound. Let's see how to use super and extends when you declare a generic type. Well, first of all, this is a comparable pair, which basically extends the previous definition of pair that we have seen before. So always, whenever you declare generic types, you put the generic type name, and then you put extends to specify requirements. That's always the case. But then you can use the wildcard. For example, I require A to be comparable. We could put here comparable of A, but instead we have used the wildcard. And we are saying here, okay, A should be comparable of not only of A, but of anything that is a super type of A. For example, A may be integer, and then comparable could be comparable of object, because object would be a super type of A. And then here basically we are extending pair of AB, and then implementing comparable of what? Of a comparable pair, right? Because we are declaring the class comparable pair. Then we declare a constructor, and then because this class is going to be comparable, then we need to implement compare2 of what? Of a comparable pair of A and B. And then because both types A and B are comparable, then I can use compare2. If A and B would not be comparable, I would get a compile error in this line and in this other line. Right, let's see an example of using generic types. I have here an interface transform, which is a generic interface with two parameters. Basically, the idea of this interface is that it will support objects that transform an element of type A into a type B. Then I will have, for example, a class string transform that implements the interface. It will take any object and produce any string. How will this class do it? Well, it will implement this required method just by calling toString on the element. Recall that because element is an object, it will surely have the toString method. Then, and that's the point of this example, I will create what we call a transform list. This is a generic class. It's a generic class that implements a list of B. The purpose of this class is that this class will hold internally elements of type A, but externally it will behave like a list of elements of type B. And for this purpose, it will, in the constructor, take a list of A and take a transformer from A to B, so that whenever I get an element of the list, I will use the transformer to transform from A to B. Let's study more carefully what are we doing here. Well, I declare my class with types A and B, any type, no requirement. It will extend abstract list. What is an abstract list? Well, remember when in the collections, abstract list is a reference implementation for the interface list. It's an abstract class that is provided in the library that only requires you to implement two abstract methods, which are get and side. So it's a quick way to implement your own type of list. And then we implement list of B. What do we have as attributes? Well, we have a transformer from A to B, but you see that is not only from A to B, we are more general here because we can transform from anything that is A or a supertype of A into a type B or any subclass of B. Therefore, I can pass here as parameter more types of transformer. I'm not only restricted from A to B, but from a superclass of A to a subtype of B. Same thing with the list. The list here does not only hold A's, but can hold any subtype of A. And then in the constructor, I'm basically just copying these attributes, these parameters into the attributes. In the get, because I should provide now a B, but in the list I have A's, I basically call transform from the transformer, and then and the element is taken from get. Right. So how do I use it? Well, here I declare a class person, basically holds name and age, has a constructor, has a toString, and has a getter, and then I create an array here of person. Then I can declare here my transform list from person to string by providing here a list of people, and by providing here my transformer from string to list. But you see here that we are being more general, right? Because transform to list goes from person to string, but this transformer goes from object to string. We are okay because if you recall, in this transform list we not require the transformer to go from A to B, but from A or any superclass of A in this case object, into b, string. Right, so how can we use this variable? Well, we can call get, and recall that inside this will hold a list of person, but externally when I do a get, I will obtain a string because the string transformer is going to be called. Then if we execute this, we print the first element and then we print the list. When printing the list, basically will call the toString of abstract list that will print the elements of the list. Genericity is not only applicable to classes and interfaces, but also to methods. Therefore, we can have methods even inside classes that are not generic, that are generic. So I can have a generic method copied to array, and I declare that this method is generic because I declare the generic types right before the declaration of the method. So I'm saying here that this t is a generic type, and therefore I can use this generic type here in this parameter, and also in this second parameter I can say that a list should be a list of what? Of anything that is t or extends t. And then t can be used here as a generic type. Basically what I'm doing here is I'm traversing the list and I'm copying this into the array. This will work here because the list is of type t or a subtype of t, and then this assignment will be correct because t will always be compatible with this array. How can we use it? Well, I can declare here an array list of a string, add some elements into the list, and then I can declare here an array of object. Calling this method is okay because array at runtime t will be object, and this type here will be string. That satisfies this requirement because a string extends object. Generic methods can have more than one generic type. For example, the method copyArray that I'm declaring here has two parameters, t and s, and s is required to be t or any subclass of t. Then this method, what it does is basically copy the source into the destination, and that's why we require this compatibility, because the source will be a subtype of the destination, this assignment will work. So I can use this method this way, so I can copy, for example, a string array into an object array. By the way, in these examples, all these methods are static, but generic methods do not need to be static. Normally, you don't need to do anything special to call a generic method, but sometimes the compiler will not be able to infer what is the value of a generic argument. Let's see an example. This method as is generic. It declares a generic type R, which actually is the return type. So already here you can see that there might be a problem because the generic type is used for return. And here we have the first parameter is a list of R or any superclass of R, and the second is just an integer that is used to get the element at that position, and here we do a casting. So the list is R or any supertype, and here with this casting we are downcasting to R, so therefore we may get a runtime error. Here we create an array of objects, but I'm populating this array, this list, with an integer. And I would like to call as to return integers. So R is integer. In this case, the compiler may not know what do I want to do if I call as just like this. Therefore, I need to specify that I want R to be integer. And that's done using this notation here. So util is the name of the class, because as is a static method, I can put here as, but to specify the value for the generic arguments, I put here the brackets and then the value of the specific type, which is integer in this case. this execution doesn't fail because the casting will succeed because I have here an integer. Okay, this finishes with the introduction to generic types. I would recommend you to study the slides in detail, try out the questionnaire, and also the exercises.